I just wanted to walk you through how we do one of these examples using a z-score. Okay, so we've got, these are not the most exciting examples, but we've got coffee containers, okay? So we've got a little coffee container, okay? And, you know, things vary. So we're trying to figure out if it's working correctly, okay? So the problem gives us a bunch of information we need, okay? So they're supposed to be full of 200 grams of coffee, okay? We've got a standard deviation of 18 grams, okay? Now, we're only interested if the coffee might have less than 200 grams, because people tend not to get upset if they're over-rewarded, but they get upset if they're under-rewarded, okay? And so we've got a sample of 36 and a sample mean of 195, okay? So let's talk about this, okay? So we've got a standard deviation equals 18 grams. We have an N equals 36, a sample mean of 195, and a mu, or population mean, that should be 200, okay? So if we want to find out if this is working well, we can use the formula you just learned in your notes, okay? Now, for example, here, this gives us a moment to think about hypotheses, okay? So since we're concerned it's only about falling under, okay? That means we have a one-tailed hypothesis. So we're only concerned about the rejection error on the one side, okay? So let me go to the solution. All right, well, let me get rid of these things for you. You need those, okay? Okay, so, sorry, erasing. Okay. Okay, so, okay, we have our null hypothesis is actually that the population mean, or it should be greater than or equal to 200. We're concerned, or our test hypothesis is that we're checking is that the mu is going to be less than 200. And like I said, we have the one-tailed test, okay? So we have a level of significance, which is 5%, okay? And that means the z-critical, okay, is 1.645, okay? Now, if you go back to the z table that's earlier in the slides, you can see the point where you have 45% of the data between that point and the mean is 1.645. So if you think about it this way, here's a really bad drawing of the normal curve, okay? And here's our mean, okay? So we're trying to find the point where there's 5% over here, which means there's 45% between here and here, okay? So that's where we get this 1.645, okay? So we can decide to reject, okay, our null hypothesis if our z-critical is bigger, right, than our z calculated or obtained, okay? So we're going to use our formula, z equals x bar, which is our sample mean, minus mu, okay, over standard deviation of the mean of x, okay? So, not a problem. We have x bar and mu, we have those, right? This is this 195 minus 200, okay? But to get this sample standard deviation, okay, we've got to do some calculations. And this calculation is right here, Okay, so we take the population standard deviation, which was 18, see that right there, and then we divide it by the square root of 36, which is our sample size, okay, which gives us 3. So what we have is then that will give you minus 5 over 3, which should give you negative 1.67. Okay. Now, since our z calculated, okay, which is this, is less than our z negative critical, okay, or making it just a negative 1.645, we can reject the null hypothesis. We are in this area over here, okay? So there is sufficient evidence to say that the process, on average, is injecting less than 200 grams of coffee, okay? So that's just simply how we do one of these. You need X bar, you need mu, you need either a population standard deviation and a sample n, or the sample standard deviation, and you can calculate the one sample z-score, okay, and test to see if it's significant. Okay, that's just a little math for you. Talk to you later.